All right, today we're on a mission. We're going to treat quadratic equations not as some scary math problem, but as a code. A code that, with the right tools, is just waiting for you to crack it.
I mean, have you ever looked at a rocket's flight path and wondered about the math behind it? That beautiful, perfect curve is called a parabola. And it's not just a random shape, right? It's a super precise mathematical curve you see everywhere, from a basketball shot to the shape of a satellite dish. And what's pretty amazing is that we can describe that entire journey with just one little piece of code.
And here it is. This is the standard form of a quadratic equation. Think of those letters, A, B, and C, as the secret numbers, the settings, really, that define the exact shape and position of that curve. So our job today is to learn how to read this code, break it down, and figure out what it's really telling us. Okay, before we can tackle the full quadratic code, we need our first and, honestly, most important tool. This is the one step you should always take first when you see a polynomial. It's called the greatest common factor, or GCF for short, and all it is really is the biggest number, and hey, sometimes a variable too, that divides evenly into every single piece of the expression. It's kind of like the shared DNA of the code. Let's look at a super simple example here. On the left, we've got 4x plus 12. So ask yourself, what's the biggest number that goes into both 4x times and 12? Well, it's 4, right? So we just pull that 4 out to the front. And then whatever's left inside the parentheses is just what you get when you divide each of those original parts by 4. See that? So much cleaner. That's simplification. I'm going to say this again because it is that important. Always, always, always check for a GCF first. Seriously, pulling it out just makes the rest of the problem so much easier to solve. It's like clearing all the junk off your desk before you start the real work. All right, we've got our first tool sharpened and ready. Now let's get to the heart of the code, the trinomial. And for this, we're going to use a really cool visual method to decode it called the area model. So here's the deal. When you're staring at that ax squared plus bx plus c format, the whole game is basically a number hunt. It's a puzzle. You're looking for two secret numbers that have to multiply to give you that c term at the end, but they also have to add up to give you that b term in the middle. And this is where the area model makes things so much easier. First, you just draw a 2x2 box. Your x squared term, that goes in the top left. Your constant c term goes in the bottom right. Now the puzzle. Find two numbers that multiply to a times c and add up to b. Once you've got them, they go into the other two boxes, each with an x attached. And from there, you just work backward to figure out what factors on the outside of the box would create that area inside. It's pretty slick. And boom, here's what a finished one looks like. For x squared plus 10x plus 16, we needed two numbers that multiply to 16 and add to 10. That's 8 and 2. Perfect. So we pop in 8x and 2x. Now you just look at the sides of the box, and there they are. The factors are just sitting there waiting for you. X plus 8 and x plus 2. We've cracked it. And hey, here's a little cheat sheet to make that number hunt go way faster. If your c term is positive, you know both your magic numbers will have the same sign. Which sign? Just look at b. But if c is negative, you know your two numbers will have different signs. One will be positive and one will be negative. It's a super helpful shortcut.
Now, factoring is cool and all, but the real goal is to solve the equation. And for that, we need the master key that unlocks the final answer.
This key is called the zero product property, and it's so simple but unbelievably powerful. All it says is this: if you multiply two things together and the answer is 0, well then one of those two things had to be 0. There's just no other way to get 0 when you multiply. So let's apply that logic. We factored our equation and we got x plus 8 times x plus 2 equals 0. Using the zero product property, what does that tell us? It means that either the first part, the x plus 8, is 0, or the second part, the x plus 2, is 0. One of them has to be. And this is the moment the code reveals all its secrets. We set each of those factors equal to 0, which gives us two simple little equations to solve. And when you solve them, you get x equals -8 and x equals -2. Those are the solutions, the roots of the equation.
So why does all this matter? Well, this isn't just some textbook exercise. This is a critical skill you'll need for things like standardized tests. So let's see how our new code-breaking skills hold up against a real problem.
Here's a question from a release state test. Take a look. What's the very first thing we should do? That's right, look for the GCF. In this case, 5 goes into every single term. Pulling out that 5 leaves us with 5 times x squared minus 6x minus 16. Now we just have to factor that much simpler trinomial on the inside. And get this, on the actual test this came from, only 41% of students got this question right, less than half. But with the skills we just covered, finding the GCF, then factoring the trinomial, this question becomes totally manageable.
And let's bring this all the way back to the beginning. Those solutions we find, the roots, they actually have a visual meaning. They are the zeros of the function. And on a graph like this one, they are the exact points where that parabola crosses the horizontal x-axis. The algebra and the picture are telling the exact same story. How cool is that?
So, what's the key takeaway from all this? Well, we've built a really solid foundation for cracking these quadratic codes. The takeaway is this. You now have a repeatable process. Look for the GCF, use the area model to find the two magic numbers, and then use the zero product property to find the final solutions. You can turn a problem that looks really complicated into simple, understandable pieces.
But here's a final thought to leave you with. Sometimes you'll hunt and hunt, but you won't find two nice whole numbers that work. The trinomial just can't be factored. So does that mean there's no solution? That the code is uncrackable? Not at all. It just means we need to pull out some more advanced tools like completing the square or the quadratic formula. But that, well, that's a story for our next explainer.